Hello and welcome everyone. I'm Michelle Jacobson, the Assistant Editor of GIE Media's Manufacturing Group of magazines. Today's medical developments, aerospace manufacturing design, today's motor vehicles, and today's e-mobility. I'm excited to welcome our speaker, Mark Lilly, the President and CEO of LillyWorks. Mark's passion is helping manufacturing companies improve their business performance using the latest technology. Leveraging his degree from Cornell in computer science and psychology, his 30 years of experience working directly with manufacturers in the latest Industry 4.0, IIoT, and machine learning AI knowledge, Mark is eager to show where manufacturing's true potential for improvement lies. Mark comes from a strong family background of helping manufacturers with production management and control. His father and brother created several manufacturing software applications designed to help companies with shop floor scheduling and material planning, the latest being Predictive flow manufacturing. But even the best software can't do a thing without an implementation plan that focuses on delivering the desired results. It's all about motivating people to modify their behavior to support the actions necessary to affect the desired change. After acquiring a foundation of knowledge, he's continued to learn both the technology and people side of the equation in making significant and lasting changes in the business performance of a company. In today's presentation, Mark will discuss using digital transformation of existing work order job information into actionable, real-time, relevant intelligence to drive prioritization of shop floor execution. He will then show how predictive analytics and computer simulation can be used to show future shop floor capacity loading, identify bottlenecks, and evaluate different what-if production scheduling scenarios. Now, let's take a dive into insights and advantages of using digital transformation and predictive analytics. Mark, the floor is all yours.
Thanks for attending, and I'm pretty excited to show you today how we're taking an approach to use digital transformation and predictive analytics to solve production scheduling. You know, what does it mean really to solve production scheduling, right? Well, I think at the end of the day, most manufacturers are looking to answer these types of questions, really these four essential questions, right? And that is, at any work center or shop wide, really what job, what work order should we be working on right now, right? Do I have materials for that job, right? Obviously we can't do it unless the materials are there. So if I do I have them, and if I don't, when will I have them, right? How is the job progressing? Where is it, right? How is it coming along? Or all my jobs, right? And then finally, and the first three are mostly kind of the here and now questions, right? They're kind of right now type of information. But this last one is kind of future looking information, right? And this is where predictive analytics in particular is going to come into play. And that is being able to answer, when can my customer get my order, right? Based on everything else that's going to be going on, that is going on, and is going to be going on in my shop, okay? So what I'm going to do really very much upfront is kind of give you the answer. In other words, I'm going to show you in a few slides right at the beginning how we answer these questions, okay, using digital transformation and predictive analytics. So you're going to pretty much get the entire message in the next, say, 5 or 6 minutes. And then I'm going to go into details about what's behind it, okay? So how do we apply digital transformation to the data that you have today to answer these questions? So we're going to take your work order and operation information that you have today in your ERP, If you don't have an ERP, that's okay. If it's in people's heads, it's probably on paper. If it's not in an ERP, we'll be able to take that information and we can give you a place to store it, to create work orders as well. But for the most part, I'm going to assume that you have an ERP that has work orders and the operational routings in them. Okay. We're going to take that information, we're going to transform it, and in real time, we're going to publish shop floor priorities so that everyone out in the shop has really no question, and they believe that the one on the top of the list, the one in red here, is the one I should be working on next. Okay. And again, we'll get into why this. We'll be able to show you what the status of all your jobs are, right? So if you have hundreds or thousands of jobs in production at any one time, we're going to show you how they're tracking. Okay. And that's essentially what this production heat map is showing you. And then I can drill into a job, right, and find out what its status is. So I can see where it is now, right? So here's today. I can see what work I wanted to have completed or I want to complete. What have I done so far? What work do I still have left to do? And probably as importantly, how much time left do I have before my due date to do that in? Okay. So those are kind of the here and now questions, right? And then we apply predictive analytics to this information as well to be able to answer those future looking questions in terms of when can I get my order at the job level, but also at a higher level, what's going to be going on in my shop in the future? Where will my bottlenecks be, right? What will be the severity of those bottlenecks? And be able to do comparative analysis against what ifs as well. So we take this information, essentially just like this job status I was showing you prior, and we run a predictive analytics tool against it, okay? And it's essentially, it's very different than a traditional scheduling program. We'll talk about that. But it's essentially doing a simulation of how work will happen based on the prioritization in that previous display, right? So even though this is showing me I'm here today, I've got, looks like the other half of operation 20, 30, and 40 left to be done based on all my other work that I will have going on in the shop. When will I be able to get those operations out? Well, that's what my simulator or my predictive analytics is going to be able to show me, okay? So in spite of this looking, theoretically, I could get this done in 2 days from now, but based upon everything else that's going in on the shop, right? It's not that easy, right? Because there's contention going out in the future. There might be material issues that you can see. So I can see big picture where my bottlenecks are going to be, and then I can click on any one of these. It will bring up that status display as well and show me specifically where, when, and how I'm going to be able to get this particular order out, considering all of my jobs out in the future. Okay. So that now when this program runs, it's actually keeping track of these predictive analytics and storing them as well. So I can go in and see what is my predicted future wait time on every operation out in the future. I can see predicted future wait time by work order, and I can see future predicted wait time by resource as well, just to name a few. So I can take that information and see which resource, which department, which machine or groups of machines are going to be my major constraint out in the future, and then start to do what ifs against that, right? So whether I modify working calendars or how people or work could be moved to different departments, I can see what the overall effect of that is based on my predicted days late in the future, or even against an alternate game plan. And if I choose to, if you want to bring in value of work orders, whether it's based on the actual sales orders or a value, even a contribution margin value, give a job, then that can come in. You can do that based on financial information as well. Okay. So that's the answer. That's how we apply digital transformation and predictive analytics to solve those essentially those questions that folks have, what they're looking for from a scheduling tool. Okay. So let's go into some background here and talk about some details about how we came up with this and kind of a deeper analysis in terms of what's behind this idea and this approach to solve production scheduling. So why is production scheduling so hard? I'd like to talk about, and you can ask this to yourself if you're a operations professional, right, working in a shop, either as VP of director of operations, maybe you're a production manager, maybe you're an operator. But these are some good questions to think about in terms of kind of answering or seeing for yourself how complex production scheduling truly is. Okay. So in your shop, how many jobs or work orders are you managing at any one time in WIP, right? Is it just 50 to 100? Is it in the low hundreds, high hundreds, 1,000 work orders or more? Okay, we've seen shops across the board, right? And really regardless, it's, you know, whether you're doing 50 or 500 or 5,000, it's a lot of jobs. It's a lot of different things you're trying to manage. Each work order has its own due date. And then of course there's a series of operations on each work order too, right? Which is adding to the complexity. So how many operations on each work order? Some companies have 4 or 5, others, you know, 10 or a dozen, others have 20 or 30 operations on each work order, right? So and regardless, whether it's just 4 or 40, it's just adding now to the complexity. How about subassemblies into the mix now, right? So are you producing just a single level part, taking material, running it through a series of operations, or is it multi-level with a few dependencies, right? Where each of these subassemblies is actually required, right? Needs to be there before this welding operation happens, right? So this could typically be up to 4 work orders somebody's trying to manage separately, or maybe you have them linked to sub-jobs. Some systems support that as well. But regardless, this adds again to the complexity of what we're trying to do with scheduling. And then some companies go really deep, right? And we've seen them much deeper than this, as I'm sure you have. This is just 5 or 6 levels deep. Some companies' product goes 9, 10 levels deep or more. Okay? And again, these may be being produced specifically for and in the same lot quantity as their parent, or there may be common subassemblies, right, that are used. So I need to have them on a separate work order because I'm making many of them either for stock or for common parents that will need them now or in the future. Okay, so again, this gets. I'm just going through these questions to show you the level of complexity that folks today in North America are dealing with in production. And now somebody, probably you or somebody close to you, one of your peers, owns getting each of those work orders out to the customer based on a due date that's been assigned, right? Either by sales or a lead time that you have or what have you. But somebody's trying to manage all this work and trying to figure out what needs to go where, when, to add to the complexity. Maybe things go outside for heat treating or plating, right? So this is a very, very complex problem, okay? Getting all those orders out on time. Managing production is very difficult. There's a huge amount of variability, literally a lot of moving parts. So it's no wonder that most manufacturers struggle with this idea of scheduling and planning for and getting the materials to match that schedule as well. Both of those things are a struggle. So typically what we see is they're managing this on whiteboards. They're using spreadsheets, or they're struggling with some very sophisticated scheduling type of algorithm tool, right? So why the struggle with spreadsheets? Well, if you're doing it today, it's probably fairly apparent, right? It's very time consuming. It's really just giving you a picture. You're spending a lot of time just trying to get a picture of what needs to be done right now. There's very little future visibility. And again, every day things are changing in production, right? With your customer orders or what's happening in production. So the spreadsheets need constant and frequent updating for whatever priorities you're generating for today to be even somewhat accurate. Why the struggle with ERP and APS systems? Well, there's a number of reasons, and if you're in that group of folks who have attempted to use the scheduling in your ERP or bolt-on APS systems, you're familiar with these. One of the, just kind of right out of the box, one of the expectations a lot of folks have with a scheduling tool is that it's going to give me an optimal schedule, right? Well, unfortunately, and I won't go too deeply into this, I'll refer you to Wikipedia where there's a detailed description about this if you look up the job shop problem. Essentially, all it says is that there's no such thing as an optimal production schedule. Okay? In other words, the nature of the problem, the variability with it, and the computational complexity of trying to optimize your set of work orders through your resources simply cannot be solved by a computer in a reasonable amount of time, okay? Reasonable meaning it would probably take, if you had 25 work centers, it would probably take something like 350,000 years, okay? So it's essentially a non-solvable problem. Now, so the question then becomes, well, if these scheduling tools aren't giving me an optimal solution, then what are they doing for me? Well, essentially, they're doing a capacity loading algorithm, is what a typical finite scheduling program does. Forward, backward, finite, infinite, combination of those things. And it's essentially loading up your capacity in one way or another, okay? And it's useful information, kind of show it's better than an infinite schedule, certainly, where capacity is not taken into consideration. But it doesn't, one of the issues with it, among many, is that it doesn't really reflect, once the program runs and you print your dispatch lists, you send them out to the production floor, and the folks out there look at them and go, where did you come up with these priorities, right? There's a lot of disconnects along that way, because it's not really reflecting how production happens. The other issue is simply, in manufacturing, we know, to put it politely, stuff happens, right? And that variability isn't taken into consideration in a scheduling program either. To use an example, in a backward scheduling mode, for example, if you think about it, what we're doing is we're telling the scheduling program, okay, let's plan to finish the last operation of every job the day it's due. Okay, when you think about it that way, you kind of go, wow, that's kind of crazy, right? I know stuff happens in manufacturing, and to plan on it actually finishing the day it's due is a little crazy in terms of planning in a manufacturing environment. So there's a lot of variability, and what we should be doing is acknowledging that and even anticipating it, and we'll talk about that a little more. Why the struggle with MRP? Well, we see this a lot is where folks, especially where folks have subassembly work orders that they're trying to manage. I'm going to need this. This is a grandchild for a child, which is required for a parent. That's just 3 levels. Others have 5 or 6 levels, as we talked about, right? Where there's that many levels, we often see folks have at least one person, sometimes even 2 or more, whose job it is just managing the due dates across these work orders, so that there's some semblance of reality in terms of when these children are truly needed for its parent, okay? So this is gonna help with that as well. So what are the symptoms of struggling with managing production? It's pretty apparent, right? You see lower on-time delivery percentage that you'd want. Lead times are longer than you'd like. You've got a lot of WIP, a lot of material, a lot of jobs out in the shop, kind of things, a lot of bottlenecks, and they move a lot from one work center to another. As a result, there's a lot of expediting. Sales and customer service is frustrated because they can't get a decent answer to their customer in terms of when you're going to get the order out to them. You may be losing new business or even existing customers is sometimes what we find with this. And certainly financial performance of the company could be stronger. Okay. So how do we fix it? And what are we doing here? Well, we're essentially going to fix this by replacing the entire scheduling and even material planning approach in an MRP, okay, or in an ERP system. George Plossel was one of the fathers of MRP back in the 60s and 70s. And in 1975, I think it was earlier, but Joe Orlicki used this quote from his friend George Plossel in his MRP book. And it's a little ironic. I point that out because it's a little ironic that the fathers of MRP truly had the best intentions in mind, and MRP was probably a pretty good first cut in terms of where we were. But their idea, their goal was this, and that is that their realization, and George's first law of manufacturing, is that all benefits in a manufacturing company will be directly related to the speed of flow of information and materials. Okay, so what does flow mean? Okay, so what we're going to do here, and the idea is that we're going to take the data you have today, digitally transform it, okay, from your ERP to get a certain set of answers. Those are the here and now answers, and then we're going to apply predictive analytics to it to get those future-looking answers. Okay, and in so doing, we're going to transform it into the information that's going to enable your operations folks to make the right decisions to improve flow in production. So that those struggles, all those symptoms, now become benefits and strengths of your company. Okay, so poor on-time delivery turns to excellent or high on-time delivery. Lead time shrink, WIP is reduced, so whatever is in WIP can flow faster through production. Expediting becomes a rarity, the exception rather than the rule. Sales and customer service can answer those future-looking questions. You're winning more business with shorter lead times, with better customer service, and the financial state of your company is going to reflect that with much better cash flow as well. Here's how we do it. So again, I'm going to assume that you have work orders and operations with some, with information in it that you're somewhat satisfied with. Okay, and the reason I say that is a lot of scheduling tools require you, for example, to have really accurate setup and run times in operations. Okay, why? Well, it's because those times are what's going to be used to create the schedule, right? In our tool, it's nice to have accurate setup and run times, but it's not critical. And you'll see why that is in a moment, okay? So we're gonna bring over this information from your ERP, okay? So whatever it is you're using today, we're gonna connect directly to it, okay? We can, during a sales cycle, I'm happy to take a spreadsheet you could provide, and we can connect to it during a sales cycle as well. But once you're a customer, certainly we do a direct integration with your ERP and pull this information out on a periodic basis. Could be once or twice a day, could be every few minutes, okay? But essentially, we're going to bring over your work orders, the operations they need to go through, the resources or departments you've specified, the work centers, whatever setup and run times you have in these. And materials are frankly optional, right? Now, if you're doing manufactured sub-assemblies, you're going to want to bring those over. But in terms of raw materials, if you want that visibility, wonderful, we can bring them over. If it's more important just to do priorities of through work centers, you don't necessarily have to. So here's what happens. And again, all this information up to this point is coming over from your ERP, okay? So here's the due date, comes from your ERP, from the work order header, right? Here's the operations that came over with it as well. Now, the width of these operations is going to be based on whatever setup and run times you've got in your ERP. Now, you know, and I know if we were to release this work order right on Monday afternoon, there'd be very little chance really that I'm actually going to get it done in perfect sequence for Wednesday afternoon, right? We know there's contention between resources with other jobs, stuff's happening during operations and so forth. So we need some time protection here, right? We want some time protection. And I'm sure you have some time protection baked in already to your lead times, right? If you were to ask yourself, well, what's the typical lead time of a job going through my shop? You might say, you know, sales is quoting 6 weeks, right? Well, if you look at that type of job and then ask yourself, all right, if nothing else were in the shop for just that job, how long would it actually take for it to get through all of its resources? And the answer, you know, we typically hear is anywhere from, you know, maybe a week, sometime out of the whole 6 weeks, right? It would really only take a week, maybe even only a few days, sometimes even a day or less, right? So the point is we're using a buffer today, right? So now we're going to acknowledge that, and we're going to think about what should our time protection be, okay? And there's some real opportunities there, okay? But in general, what we're doing here is we're breaking this up. So we have our time protection and we have our work here specifically segregated and separate, okay? So the point of this is to anticipate variability that we know is coming down the pike and to protect our due date, okay? So we work with you, there's a number of exercises and there's a number of methods to appropriately size this time protection. But what's most important is that you're comfortable, that you have the input and tell us what size these should be so that you're comfortable with these time frames, okay? And as a result of doing so, then what do we get? Well, over here on this left-hand edge, what you have now is the right time to start the job. And this is a big struggle for folks, right? A lot of companies, a lot of folks in production don't have that visibility of when the right time to start a job is. So what happens? Well, I know if you know my butt was on the line and I'm in production, and I can't see when I should start it, I'm going to start it early. Right? I may start it really early. And what am I doing while I'm doing that? I'm telling somebody that I need materials a lot earlier than I probably need them to, right? Tying up cash and company resources. So this now allows me to give me not only an objective time to start the job, but also an objective time as to when I really need materials, okay? Now, one of the other opportunities, as I said, say you have a 6-week lead time. When I implement this, I can say, well, you know, I'm quoting 6 weeks on something that really only takes, say, 4 days to manufacture. If I had visibility of what I should be working on truly out in the shop and when I should be releasing jobs and working on things, shouldn't I feel comfortable maybe skinning that down even just by a week? So maybe I could bring that, you know, say 5-week buffer down to say 4 weeks. So my total lead time is just 5 weeks, right? That's kind of where we guide folks to start. So what's happening there's a number of things happening, but one of them is that now my job start time is moving up and I'm not releasing that job into production for another week. And I may be doing that across tens or hundreds of jobs. That's going to give me an immediate reduction in work in process, okay? And what happens in work in process is there's actually a mathematical Q theory law. There was a fellow named John Little who studied at MIT in the 50s, and he came up with Little's law. And it simply states that the more things or people or items you put into a system, and in Q theory, a system can be, you know, a highway, an amusement park, a manufacturing shop floor, right? So you come down an on-ramp onto a 5-lane highway, and all you can see is brake lights, right? Everybody going about 10, 15 miles an hour. You know you're going to be on that stretch of highway a whole lot longer, right, than if everybody were whipping by you at 70 miles an hour. Same sort of thing in amusement park, right? Now, probably pre-COVID, but If you go to an amusement park spring break, say you have a list of 5 rides you want to go on, you're going to be at that amusement park a whole lot longer than if you go, you know, say this time of year when everybody's back in school, or a lot fewer people that are there, right? Same thing in a manufacturing shop floor. The more work orders, the more jobs you send out into WIP, the longer period of time any one of those jobs or work orders is going to be in WIP. Now, the neat part about this is that the inverse is also true. The fewer jobs I send out into WIP, the faster any one of those jobs is going to flow through all of its resources to get done. Okay. So now we take another look at this. What are we doing? We're controlling overall how much WIP we're going to send out to the floor, implementing Little's Law simply by that visibility now of when I should be starting the job. So whatever is in WIP is going to flow through a lot faster, further reducing my lead times. Now, the other thing that's happening with this this structure, and by the way, I like to call this structure where we have the work and the time protection and the dates on either end. I like to call this an execution plan. In fact, what this is a custom execution plan, because our, you know, in a custom job shop or custom manufacturing, certainly the work needs to be done is going to be different, and I can put rules in to create my buffer differently as well based upon this custom job. So it's a custom plan for every work order. Now the question becomes about that prioritization. So what are we using for prioritization? And pretty much any scheduling tool you find you find these days is using a due date priority, which seems to make sense on the surface. I mean, due date is an incredibly important piece of information. That's your commitment to your customer. But here's the problem. In a high mix environment, right, which most manufacturers in North America are today, is you will have jobs that are due, say, 2 months from now, that are much more in danger of being late if you don't get started on it today than a job that's due maybe just a week or 2 from now, right? So if you're prioritizing by due date, you're going to pay attention to those jobs that are due earlier at the expense of the ones that are due later, but because they either have more operations or have to go outside and back 2 times, that type of thing, are actually more in danger of being late, okay? So the more you delay them, the later, and then you find yourself in this constant expedite mode. So we're going to show you a prioritization method that solves that, okay? So here's my execution plan, right? Here's today, this gray line. There's the work that's already been reported complete. Here's the work that remains, okay? Now from here to the end of my time protection, that's the time protection remaining, okay? The priority, you don't have to run a scheduling program. It's always calculated and in real time. The priority is the percentage of work remaining divided by the percentage of time protection remaining. We call this value a threat level, okay? So very simply, if I'm doing work faster than time is going by eating my buffer, then this threat level value is going to go below 1. On the other hand, if I'm not reporting work complete as fast as I want to or should, but time is getting eaten, right, faster, then that threat level is going to go higher and higher than 1. Okay, so we take that information, and again, as soon as it comes over, as soon as your information comes over from your ERP, it's digitally transformed into this execution plan. The transformation happens further into a threat level priority, and that's displayed electronically in real time out in the shop. Okay, so that everybody can see by a group of departments, the shop wide, or specific to any department, machine, even person, I can see what job should that resource be paying attention to right now. In layperson's terms, which job is most in danger of being late? That's the one I want to pay attention to right now. Okay. Now, where you have a multi-level type of structure, okay, and these could be independent work orders in your ERP, And when we pull them over, we could leave them as independent, or we could also take the opportunity, if you're truly making these subassemblies specifically for and in the same lot quantity as the parent, then it may make sense to tie them together like we've done here. So I need all three of these subassemblies before I can do this weldment, right? So what we get when it's structured this way is it's transformed digitally into what we call a multi-level execution plan. Okay? So here's that top level, which is buffered against the shipment date or the customer want date. And then each of the subassemblies, again, may have its own work, its own buffer sizing based on what it is, where it's going. And they're all timed and synchronized to make sure they're going to be complete by the time I need it in the welding operation. Okay. Now, here again, if all your work orders are separate, in other words, you're building subassemblies, whether they're for common parts, whether they're for stock or going to stay in WIP and go to a number of different parts, then we can also take those disconnected work orders, bring them in, and that poor soul who is working on trying to manage those due dates, well, you can reallocate that person now to a better, more value-based type of role in the company, because we're going to take that information and we're going to transform it for you like that into this type of picture. Okay, so we're literally going to change the due dates on all those dependent work orders. You can even bring in sales orders and change the top level dates as well to match the sales orders. That's up to you. How are all my jobs or work orders tracking? Well, here again is that production heat map, right? So essentially, now that we understand that threat level value, that's the data that's being used to show the information here in the heat map. So right now, where are all my jobs based on their threat level value? Okay, so a 1 indicates there's simply one job in that threat level area on the heat map. 2 means there's 2 jobs there. So if I were in the software, I could click there, it would show me the list. I've got 26 jobs that are either just released or about to be released, right? So you can click on any one of these, and again, it's going to bring up that execution plan and show you where that is. So if I've got the ones in blue, I've probably released too early, right? I've reported work complete even before that buffer started on the left-hand edge, remember? So, maybe okay if I'm not sharing resources over here with these jobs that are trending late, right? So this is trending late. Anything that's up against this wall here is either, it means the buffer's gone. So it's either definitely late now, or it's definitely going to be late based upon the amount of work that still needs to happen. And again, you can click on it and drill down and see specifics. Okay. So that's what we've covered so far, is really just the here and now questions, right? What job should I be working on right now, shop-wide or any resource? What's the status of specific jobs or all my jobs, and how are they progressing, right? And also, where are my materials, right? And do I have materials? If, again, that's optional if you want to bring materials into the picture. You'll be able to see that as well, okay? Because that priority list, for example, can show all jobs in the priority list, or it can show just the ones that I know I have material here waiting to be worked on, okay? How about those future-looking questions, right? So, and the big one is how can I tell my customer with some level of confidence when they're going to get their order, right? So again, we've got a predictive analytics tool. We actually it's a program. We actually call it the Predictor. You don't have to run it over the weekend or overnight. You can run it anytime during the day. And essentially, it's going to take all your work orders, either that have been released, you can include planned ones as well, and simply simulate you using, or operations using, this threat level priority out into the future and show you the results of the simulation. Okay, so on a job by job basis, you're going to be able to see, and again, in this case, I'll be able to see, in spite of the fact that theoretically I could get this done in 2 days, based on the simulation, it's showing me I'm not going to be able to get this complete. Based upon what the threat level values will be in the future for all jobs, I won't be able to get it complete until actually 2 days late, okay? So again, you can bring up the results of the predictor, and you have to be careful here because, well, this looks like a schedule, right? But this was not produced with a finite capacity algorithm load scheduling program backward forward, right? This is very different. This is showing the results of doing that simulation out into the future with all your jobs, as if everyone is following off the top of the list, that priority list out in the future. How will all my operations on every job be placed in my various resources? Okay. So you can actually literally click on this and it'll actually, like a movie, step you through it, or you can just view it. Now, this is some really useful information. So I'm seeing where my bottlenecks will be in the future, right? Just visually, I'm able to see the severity of those bottlenecks. And again, if I click on one in particular, it'll highlight all the operations for that particular work order, bring up the execution plan along with it, and show me specifically why, where, and when each of its remaining operations and how it fits into the big picture. So I can see why now, based on everything going on, why that's going to be 2 days late. Okay. So here again, and the neat part with these predictive analytics is that when this simulation program runs, it's storing what it finds. Okay, so it's literally doing the simulation and it's tracking how long it has to wait, or rather how long it will have to wait out into the future in order to be placed. Okay, so you can see that information either by work order, by operation, by resource, and you can do what ifs as well. We call them alternate game plans. So you can change calendars, you can change your resources, how many people you have in a certain department, right? What if I move these people from this department to that department for a certain time period? How will that make my shop load look? How much will I be able to reduce my days of lateness? And then again, if you're bringing value into the picture, whether a revenue or contribution margin, what's the financial impact to the company of making these changes as well? Okay. So now we've shown how we can take your information, digitally transform it, and then use it in a predictive analytics tool to show that those future-looking questions as well. So now we're answering those questions. We're not scheduling per se in the sense that, and the big idea behind this, right, is instead of trying to get my data perfect and all my parameters and everything perfect so that I can run a program to create a schedule and a plan and then attempt to execute that plan out in the shop floor. That's really where the disconnects and a lot of the struggles have been throughout the decades, frankly, of attempting to use finite scheduling, okay? So we're putting that model aside, and instead of trying to create a plan and then execute it, we're saying let's first focus on the execution on that real-time prioritization by transforming your data, giving you those priorities in real time, and then with the ability to run a program, that simulation tool, to see what your future looks like, right? So we're answering these fundamentals of managing production, right? What job should I be working on? Do I have materials? If not, when will I have them? Where are my jobs? How are they progressing? And finally, how can I tell my customer with some level of confidence when they're going to be able to get their order? Benefits, as you can imagine, are huge. And what this is really, a lot of what this is really about is simply visibility, right? Especially those here and now questions you can literally see that you'll have visibility of the answers to those questions, right? And that information is going to give your operations folks the information needed to make the right decisions to move material faster, right? And like George Plossel said, all the benefits come from that. Higher on-time delivery, lower WIP, shorter lead times, and a much stronger throughput equation from and cash flow in your company. Okay. This implements pretty quickly, and the neat part about it is it's separate from your ERP, so you don't have to re-implement your entire ERP to use this. We can just tie into the information you already have. So some companies go live in as quick as 8 weeks. Others take 3 or 4 months, but on average 2 to 3 months, and you're displaying those priorities out in the shop, right? You have that visibility of those real-time questions. Okay. If you're interested in ROI worksheet, I've got a couple of them, both from a time and cost savings, right? You probably have a lot of people spending a lot of time in production meetings and or managing whiteboards or spreadsheets. This kind of works you through what your savings would be on that end. And then there's the added value end, right? In other words, gee, if I were able to get just, you know, X%, even if it's just 2 or 3% more jobs out during a month, for example, you know, using the same resources I'm paying for today, people and machines, what would that do to my bottom line, right? So that's a very powerful spreadsheet as well. And the ROI is quick. It's months or weeks. It's not years, as you can imagine. So thank you very much for your attention. I hope you've learned a lot. We've got a couple of video testimonials up on our website. In particular, there's, and both of these folks are using different ERP systems. Arch Global Precision makes cutting tools. They're interesting in that they're a combination of make to order and make to stock. Graphicast is I think very much a machine shop and job shop. Both these companies talk about their struggles with traditional scheduling tools that they used, and how this approach helped them quite a bit. There's also a white paper on our website. Feel free to grab one of these as well. And certainly any other questions, feel free to reach out to me directly. Michelle, thank you. I think I'm ready for any questions if folks have them.
Perfect. We do have some audience questions here, and thank you for those additional links and that very insightful presentation.
You're welcome.
We have a question here. Someone wants to know, can this system lay over any ERP, or are there ERP parameters required to integrate with LilyWorks?
Yeah, like I said, it'll attach to pretty much any ERP. Now the asterisk on that, right, is and ideally the ERP is relatively modern in the sense that it has a SQL, you know, database on the back end, right? So something like SQL Server or Oracle or what have you, right? Now that being said, we have encountered some very older systems, right, that have hierarchical files and, you know, older database technologies. So we certainly can still work with those. It's more typically an extract process where we extract data periodically from that database, and then our program goes in and hits you know, update files essentially, rather than directly to the database. But if it's a SQL Server based database, then what we typically do is we have a technology, very secure, on-premise, that basically runs as a service on your computer equipment and pulls your data directly out of your database and sends it to our very secure database up on Amazon Web Services as well.
Great, thank you. We also have another question. They're wondering, how do you account for efficiency of setups? For example, part A and B are similar enough, but the priority of part C from a different setup falls in between. A and
Yeah,
B?
excellent question. Yeah, and if you recall that priority list, so there's a method we call setup code. So what you would do is you designate in what is it in part priority of part C falls in between. Okay, so B and there'd be a setup. You'd put the same setup code in both A and B. So essentially, what happens is once you start running A, the system recognizes that there's an operation below that has the same setup code, and it'll bring it up and sequence it for you on the top. Okay, and then whether or not you want to actually change or modify the setup time is up to you, right? So instead of duplicating those hours, but yeah, it'll prioritize them correctly for you. And what's neat is the predictive analytics actually will simulate you doing that as well, if that's how you have it set up. Okay. So that we'll see in the future that you're planning to sequence those jobs together, regardless of what the priority C is in between the two. Good question.
Thank you for going through that. In your perspective, what do you see as the most likely factors or liabilities that would negatively impact accurate data flow within this program?
Yeah, great question. I mean, while I did emphasize that, super accurate setup and run times are not required to use this approach, and that is definitely true. Now that being said, your routings do need to reflect somewhat in reality of what work centers the job needs to go through, right? So. And typically we don't find too many problems in that way. But yeah, kind of general data accuracy is good. Now that all being said, one of the advantages of having an application that's separate from the ERP system is a couple things. Now, what we call the integration is an ETL, or extract, transform, and load tool. So the key being that T, or the transform. So, and literally, right, digital transformation, we can take the information you have in really any state it's in and modify it so it's going to look right for us or for you in protected flow, right? So we see that a lot. One example you may have kind of referred to was where in your source ERP, you may have completely separate work orders. Well, if it makes sense to link them, if truly you're making them specifically for a parent, then it might make sense to link them, and we can do that. We can transform that information to reflect that in that ETL tool. Okay, that's just one example of many that we do. I'm working with a customer now that has, various information that they've inherited in their ERP. They have move times or even queue times in operations. They have certain operations they'd want to ignore. That's fine. We can make those adjustments in the ETL tool before it even comes into to PFM.
Great, thank you. Could you specify where exactly does it show my prediction versus my actual performance? Was that in the predictor?
That's a very good question. I'm in those visuals currently, and it's interesting because I was just thinking about this earlier in the day. What you have is, let me, if I can backtrack here. So it's a very good question. What I've got, Michelle, can you see my predictive analytics screen?
Yes, I can see
Okay,
it.
thanks. I wasn't sure if I was still showing.
Mm-hmm.
So, so yeah, this is actually the actual reported from your ERP. Okay. Now, and this is, so here's today, and this is the remainder of the work. So I've reported 10 and half of 20 complete. So I have the other half of 20, 30, and 40 still left to be done. Okay, so here's what I've reported complete, what I still need to do as of today, and then the predicted information. Now, to your point, what this isn't showing is where this actually happened. Okay, now number one, you have that information in your ERP. We're going to assume that you're reporting operation completion information in your ERP. If you're not, that's okay. We have a place for you to do it if you need to use our tool. But as a default, we're going to look to the ERP to do it. So based on labor tickets, start and stop times, and those types of things, when that was actually done. If you wanted to bring it into if you wanted to bring that level of detail into our system, you can do that, and then do reports against it. So where was it actually happening, that sort of thing. So yeah, it's a very good question. It's a subtle layer that we're not visually showing here. But I imagine it could be an enhancement for a future release, because it would be kind of interesting to now see, well, where even, and certainly once this is done, right, I'd want to go back and see, well, when and how did I actually do it? Now, one thing and one parameter I will note that we do is when did I finish it, right? Because that's a critical piece of information. You want to see what the trends are. In other words, if I finish this job within my buffer time, that's good. And that's interesting to know how much of my buffer did I use, right? Because if I'm finishing, every job of this type, or this part, of this sort, always in the green zone, then I probably have an opportunity, right, to reduce that buffer down. On the flip side, if I'm always late on this job, I may not have enough buffer, right? So I may want to increase it. So long answer, but very, very good question.
That was very helpful. Thank you. I think we have time for about one more question. For someone who they already have an MES system in the shop, but they still struggle getting work out on time. So could they use a PFM but keep their already existing MES?
Yeah, absolutely. And it's a great question. And we do find that from time to time. Folks have software down in the shop that's showing them priorities, but they're still struggling because you ask, well, where are those priorities coming from? And again, typically, best case, they're coming from, a finite scheduling tool. And again, those priorities aren't always truly directing you to maximize your capability of delivering your products on time, right? So when folks see this approach and understand that methodology, so yeah, the short answer is yes. We have APIs where you can take, and our database is fully accessible. Actually, you have your own database in the cloud with our software. It's not like you're embedded in a giant database with 100 of our other customers, right? But we also have APIs. So folks in this situation have used these APIs and actually take these threat levels in real time and publish them using their MES system. So yeah, get the kind of the best of both worlds. They get to keep what they're using down there. Maybe they have drawings tied in already and that sort of thing. So it's nice. But now they have PFM priorities actually driving what needs to happen next.
Great, thank you. All right, I see we are out of time for today, but Mark, I want to thank you so much for joining us and providing these great insights. It's been wonderful to go through this presentation, and I also want to thank everyone in the audience for joining us today.
Thank you, Michelle. Thank you for the opportunity as well. Enjoyed it.
Thanks. Hope everyone enjoys the rest of their day.